So, what if I told you that the planets lining up could actually predict radio blackouts right here on Earth? It sounds a little out there, I know. But today, we're going to dive into a pretty controversial theory from the 1950s that's getting a real-world test right now in 2025. Okay, let's just jump right into the big question. Can planets actually predict solar flares? I mean, it sounds like something from science fiction or, I don't know, maybe even astrology, right? But believe it or not, this is a serious question a radio engineer for a major corporation asked nearly 75 years ago. And the answer? Well, it's still being debated today. And this brings us to this wild idea of a cosmic radio forecast. We've got this old, almost forgotten theory that's about to meet a very modern test, and we all have a front row seat to see how it plays out. Our story kicks off back in the 1950s with a guy named John H. Nelson. Now, he wasn't some astrophysicist in an ivory tower. No, he was a radio engineer for RCA, and he had a very real, very practical problem to solve, figuring out why global shortwave radio signals would suddenly just die. And his solution? Well, it became known as the Nelson hypothesis. He came up with a method that basically connected the dots between the planets way out there in our solar system and the communication static right here on our own planet. His core idea is called the planetary alignment hypothesis. It basically says that when planets line up at specific angles from the sun's point of view, and that heliocentric part is absolutely key, it correlates with a higher chance of solar flares. And then, you guessed it, those flares blast Earth with radiation, which totally messes with our radio signals. Nelson laid it out as a clear chain of events, kind of like a cosmic domino effect. First, the planets line up at what he called critical angles. Think 0, 90, or 180 degrees. Second, the sun gets agitated and pops off a solar flare. Third, that radiation zaps Earth's ionosphere. And fourth, the result for us down here is a radio blackout for shortwave signals. Simple, right? But look, this isn't just a history lesson. This is all happening right now. It brings us to the 2025 test case, where this 75-year-old theory is getting put through a live experiment. So the people who follow this theory are watching two key dates in 2025. The first one already happened, a Mercury-Jupiter conjunction back on June 8th. But the one to really watch is the upcoming Venus-Jupiter conjunction on August 12th. I mean, notice how tight that angular separation is, less than a single degree. In Nelson's model, that is a huge trigger. And here is where it gets really compelling, especially for those who follow this stuff. Just 1 week after that June 8th alignment, boom, an M8.4 class solar flare erupted. That flare caused what NOAA officially called a moderate, or R2, radio blackout. For supporters of the theory, this felt like a direct hit, a prediction that pretty much came true. So what does the model predict for August? Well, this chart shows a simulation of potential solar flare activity right around that August 12th conjunction. You can see a clear peak predicted for the 12th, with things ramping up the day before and cooling down the day after. This suggests a very specific window of risk for radio communications. And this isn't just based on one guy's observations from the 50s. A 2020 statistical analysis, which looked at over 40 years of data, found a significant, non-random correlation between these planetary angles and major solar flares. So the point is, there appears to be a statistical pattern here, but, and this is a big but, is that pattern really meaningful? And that brings us to the other side of the coin, why mainstream science is still very, very skeptical. This is where we got to put on our critical thinking caps and really look at the other side of the argument. The main issue is that solar activity is influenced by a ton of other factors. For starters, you've got the sun's own 11-year cycle, which is the biggest driver of them all. Then you have to ask, okay, was the flare even aimed at Earth? What time of day is it? What radio frequency are you using? All these things can totally mess with the results. And this gets to the absolute heart of the scientific critique, the classic case of correlation versus causation. See, Nelson's data showed a correlation. Two things happening around the same time. Planets line up, radios get fuzzy. But correlation does not equal causation. It's a huge difference between two things happening together and one thing actually making the other happen.
So what's the core objection? Well, from a physics standpoint, the gravitational and electromagnetic forces the planets exert on the sun are just incredibly tiny, like basically negligible. It would be like trying to move a bowling ball by flicking a single grain of sand on it. There's just no known physical force strong enough to make this work.
So, with all that debate swirling around, what should we actually watch for? Let's turn this from a theoretical argument into a practical guide for this upcoming August alignment. If you're a radio operator or even just a curious observer, here's what you can do. First, keep an eye on NOAA's official 3-day space weather forecasts, right around August 10th to the 14th. Second, if you rely on shortwave radio, it's probably smart to have a backup plan. And third, if you do notice any disruptions, log them. We can all be citizen scientists here and compare our notes to the official data later. So, go ahead and circle this date on your calendar, August 12th, 2025. This is the moment of that really close Venus-Jupiter conjunction. It is the next big test for this 75-year-old theory. What's the sun going to do?
Which leaves us with the final big question. When all the data from this cosmic event is in, are we going to see a clear pattern, maybe confirming a hidden link between the planets and our sun? Or will it just turn out to be another interesting but ultimately random coincidence? The sky is the laboratory, and the experiment is about to begin.